Welcome, guys. Can you hear me? If you can hear me, let me know in the comments, the chat box. If you can hear me, let me know in the chat box so that I can begin. Guys, can you hear me? We're going to be starting the live session by 7:40 on the dot so that I can make sure, you know, everything is working properly. If you can hear me, please just let me know in the chat box. Okay, thank you. I can see you, Leo Tosin. Okay, it says you're audible. Okay. Um, okay. So as you can see, in the title of the stream, we are working on MEP measurements, right? So today's video is basically on electrical installation and measurement guide. So basically, this video is just to give you an introduction on how to go about electrical installation. You know, as quantity surveyors, whenever we want to carry out measurements, right, we need to have an idea of how the technology behind it, right? So as a quantity surveyor, we need to know how this electrical installation works. Good. So now let's have a brief introduction of electricity, because you cannot know electrical services without knowing what electricity is all about, right? So what does it say here? It says that electricity is a type of energy created by the movement of charged particles, most commonly electrons. It is fundamentally the flow of these invisible particles towards a conductor, which can then be harnessed to power our homes, gadgets, and daily lives. So, point to note in this definition is this: before you can use electricity, it must go through three phases, namely the generation phase, the transmission phase, and the distribution phase, right? So if we go through this definition again, what can you see? You see that it says electricity is type of energy created, meaning that it must be what? Generated. So created by the movement of what? Charged particles, most commonly electrons. It is fundamentally the flow of these invisible particles through what? A conductor. So it means that this generated electricity must pass or must be transmitted through what? A conductor. And then which can be harnessed to power our homes, gadgets, and daily lives. So after it is being transmitted, it is going to undergo what we call what? Distribution. So you can see that electricity passes through what? Three phases: the generation phase, the transmission phase, and what? The distribution phase. Good. So moving forward now, the measurement process, right? Using the standard method of measurement, which is, what we are used to. Items of measurement in electrical services are basically measured as either enumerated. And remember, anytime something is enumerated, it means that you should what? Count. Just find the number. That is what it means, right? So, or as what? Linear items, When I say linear, it means that you should measure it in what? Meters. So only few works are measured as item. When I mean item, it means like provisional works, lump sum and stuff like that. So if you are going to be measuring the builder's work, like for chiseling the walls and stuff like that, for example, the money that you will pay to the government to connect your electricity to like the main electrical cable, electrical source is measured as what? An item. So you can see what we have here. For example, the cable stroke wires are measured in what? Meters. The conduit pipes are measured in what? Meters. Primary equipment like your transformer, your low voltage panel, high voltage panels, your distribution board, they are what? Enumerated, meaning that you just count them and tell us what's the number. And then fittings and fixtures. When I say fittings and fixtures, I mean like things like your sockets, your switches, your lights, right, and so on and so forth. That is, you can categorize them under what? Fittings and what? Fixtures. So they are measured as what? Enumerated item also, meaning that you should just count them and tell us the number. Good. So moving forward, you need to understand the process of electrical flow if you are going to know how to measure, right? So like I said before, electricity it goes through three phases, right? The generation phase, the transmission phase, and what? The distribution phase. So first things first, you need to understand how this electricity is generated, right? You need to understand how the electricity is transmitted, and then you need to understand how the electricity is what? Distributed. So first things first is the generation. So you can see now what we have here. The electricity must be generated from what? A source. So this source can either be what? Hydroelectrical, meaning that it is generated using what? A dam. It can be Aeolian generation, meaning that you are using what? A wind turbine. Or it can be what? Solar generation. And I'm sure every one of us know exactly what I mean by these three sources of what? Electricity generation: hydroelectric, wind turbine, and solar generation. I'm sure most of you are conversant with it. So now look at what we have here now. It says that, note, after this electricity is generated, the amount of electricity is not enough to travel through a long distance to the national grid and to feed the needs of what? The population. So it needs to be stepped up using what? A step-up transformer. So what this means now is saying that after electricity is generated, the amount of electricity generated is not enough to travel long distances. Meaning that if you transmit the electricity you generate from either your hydroelectrical source, your Aeolian source, or your solar generation source, right, it is not going to be enough to meet the needs of what? The populace. And the second problem is that the electricity is not enough to travel the long distance to get towards the consumers, right? So how do we now, sort that? Now, for example, let's look at this practical example now so that you can understand what I'm talking about. Now, if you are Nigerian, right, you will know that we have different hydroelectric power stations. Example is Kainji Dam in Niger State, right? So we're going to be using that as an example for this video. So you see that the Kainji hydroelectric power station generates a massive chunk of what? Nigeria's electricity. Now, if you look at the generation, it says that inside the dam, the spinning water turbines generate electricity at around what? 16,000 volts, which is what? 16 kilovolts. Now look at the problem here. If you're trying to send 16 kilovolts straight from Niger State to power consumers in Lagos or Abuja, the electrical resistance of the long transmission wires would turn almost all of that power into what? Useless heat. So you see what it states here, that after you generated 16 kilovolts, right, this 16 kilovolts is going to waste on just the transmission and it will not get towards the consumers. So what do? this electricity now, the 16 kilovolt of electricity needs to be what? Stepped up. It needs to be what? Stepped up. And how do we step this 16 kilovolts of electricity that was generated in Kainji Dam? You use what? A step up transformer. Now, look at what it says. Right outside the Kainji powerhouse, massive heavy duty transformers take that 16 kilovolt of electricity and instantly step it up towards 330,000 volts or 330 kilovolts. So you see what it means? That 16 kilovolts that was not enough passed through the step-up transformer and it was increased towards 330 kilovolts. Now, this ultra-high voltage allows the electricity to jump into the transmission company of Nigeria, which we know as our national grid. Now, from the national grid, this 330 kilovolts is transmitted through a grid line, or what we call a transmission line. So you can see now that we are moving from the generation and heading towards the transmission, right? So you can see that the grid lines and travel hundreds of kilometers across the country with very little energy loss. So you can see what this thing is telling us now is that 16 kilovolts that was generated is not enough to be transmitted long distance from Niger State to Lagos to Abuja to Port Harcourt and so on and so forth. So it had to be stepped up to 330 kilovolts using a step-up transformer. This 330 kilovolts is enough to be transmitted through the transmission lines over hundreds of kilometers. I hope that makes sense. Good. So now let's move forward. The process of electrical flow now, transmission. So you can see we just moved from the generation, right? Now let's move towards the transmission. Now, once the electricity has been stepped up to 330 kilovolts, it enters into the national grid. The power travels across those massive aluminum cables suspended by towering steel towers. The giant metal pylons you see running across bushes and highways. Don't worry, I'm going to show you an image because I'm sure you've seen this before. The high voltage electricity is transmitted with a high voltage wire, usually 3 live cables. Now let me show you a diagram. Now I'm sure you've seen this thing before. If you've seen this thing before, let me know in the comment section. Just say yes, I've seen it before in the comment section so that I can know that you're following up. So as you can see, this is what we call a pylon or a steel pole, right? So now remember in the previous write-up, we said that it is going to the 330 kilovolt of electricity is going to be transmitted using a high voltage wire, which is usually 3 cables, right? So if you look at this now, you can see this is the first cable, the second cable, and the third cable, right? So you can see that this wire is on both sides. So these 3 live cables is also on this side. So what you have here is also what you have here. Look at this example also, right? You can see cable 1, cable 2, and cable 3. Same thing at this side, cable 1, cable 2, and cable 3. All transmitted using a steel pylon. I hope that makes sense. Good. So now if we move forward now, you can see that it states because the voltage is pushed towards 330 kilovolts, the electricity travels hundreds of kilometers at nearly the speed of light without minimal power loss. So you can see that our fear all along was that the 12 kilovolts that we generated was not going to be enough to travel long distance. So the 330 kilovolts that the step-up transformer stepped it up, right, is now going to be enough to travel long distances from Kainji Dam down to where the electricity is needed, right? Good. So from the national grid, the step-up electricity is transmitted to a transmission substation. Now, what happens at that transmission substation? I'm sure you're curious, right? So now let's see what happens at the transmission substation. Good. At the transmission substation, electricity cannot enter the city at 330 kilovolts. Why? Because it is far too dangerous and powerful. Meaning that if you connect this 330 kilovolts directly to your house will blow. It will turn to a bomb, right? Good. So what do we now do? The 330 kilovolt that it was transmitted will pass through our transmission substation. What do we have inside this transmission substation? We have what we call step-down transformers. Now, this step-down transformer, you can see what it says here. The high voltage lines runs into a regional transmission substation located outside or on the edge of a major city. Now, the transformer, a large step-down transformer drops the voltage from 330 kilovolts to 132 kilovolts, and from 132 kilovolts down to 33 kilovolts. So you can see that this transmission substation is also part of the national grid, right? But this one now is like a subgrid or a substation where the high voltage electricity would now be stepped down towards 33 kilovolts. Sorry. I hope that makes sense. If you get what I'm talking about, please just let me know in the comment section. Just type I understand. So now you can see what we have here. Note, this 32 kilovolt is still too much electricity and still needs to be transmitted towards distribution companies using a high tension wire. So you can see that from 330 kilovolts, it was stepped down towards 33 kilovolts. But this 33 kilovolt is still too high. Good. So since the 33 kilovolt is still too high, it needs to be transmitted towards distribution companies. Now, I'm sure you've heard of what we call AEDC, right? If you've heard of what we call AEDC, IKEDC, that's the distribution company for Ikeja. Then this one is the distribution company for Echo. AEDC is the distribution company for Abuja, right? So once this 33 kilovolts of electricity is gotten from the step-down transformer, it is not sent directly to the consumers. Why? Because the government needs to generate revenue from our electricity consumption. And how do they distribute this electricity? Through our distribution companies, which we call discos. Good. So I'm sure you've heard it on the news that there was a time that the current government was owing the distribution companies some certain amount of money, almost billions, right? That was why we were having, light issues at some point. That was because of what? The government did not or could not pay these distribution companies what they owed them. So the distribution company now decided to stop distributing electricity towards consumers. So you can see that you don't just get lights like magic. It follows a process. And as a quantity surveyor, you don't know where life takes you in the future, right? So you need to understand all these things. Because you might get a government contract where, they are going to be making a new transmission line and they are going to be needing quantity surveyors. So you also need to have an idea of this. Now, moving forward, you can see what we have here. The injection substation, the discos receive this 33 kilovolts power and run it through heavy high tension wires, still 3 live wires, right? Supported by tall, sturdy concrete or wooden poles along major city roads. Now, even inside this distribution company, the 33 kilovolts of electricity still needs to be what? Stepped down. So now how many times have we stepped this electricity down? 2 times. The first time was in the what? Substation. Now the second time is in what? Distribution company. So now the distribution company now is going to be stepping this electricity down from 33 kilovolts that was coming from the substation down to what? 11 kilovolts. I hope that makes sense. Good. Now, the 11 kilovolts travels deeper into residential areas and what? Commercial zones. Now, look at what it says here. As this 11 kilovolt is entering into commercial areas and residential areas, it is going to enter the community transformer. So you see another transformer again. This is the specific transformer you see sitting on your street, mounted between 2 concrete poles or fenced around or fenced off on the ground. I'm sure you've seen this something like this before. You've seen a transformer on top of a concrete pole or on the ground but fenced. If you've seen this type of transformer, I want to hear you say yes, I've seen it in the comment section. Good. So the 11 kilovolts electricity enters into your community transformer, right? Now this community transformer is now where we're now going to do the last step down, because this 11 kilovolts of electricity is still what? Too high for you to connect it directly into your house. So your community transformer is now going to step it down to a voltage that your house can use comfortably, so that your appliances will not start roasting or will not blow up or get burnt. Now that is what we mean here in the final step down. So this neighborhood transformer performs the final step down, converting the dangerous 11,000 volts, that is 11 kilovolts of electricity, into the standard household voltage. And what is the standard household voltage? 415 volts. For commercial use, 220 to 240 volts for what? Residential use. I hope that makes sense. Good. Now look at what we have here. Note, 3 high tension wires carrying 11 kilovolt electricity enters the step down transformer at your neighborhood. The transformer steps it down towards 415 volts or 220 volts. And then the step down transformer gives off what? 4 wires, 3 live wires and 1 neutral. So anytime you are walking around and you come across this transformer, I want you to be observant. Check the wires entering inside the transformer. They are going to be 3 in number. Those 3 wires means that the electricity entering into that transformer is electricity in what? Kilovolts. When the electricity enters into that transformer and the transformer steps it down, 4 wires are going to come out of the transformer, so that those 4 wires now are going to be transmitting the steps down 415 volts or 220 volts. Good. Which then enters what we call a feeder pillar. And then the 4 wires are transmitted through the poles to different houses, right? So what it means now is this. If you look at this diagram, right, you can see this rural power supply system. So if you look at this diagram now, you can see that 3 wires, which is carrying the 11 kilovolts of electricity. So these 3 wires you are seeing here are high tension wires, right? So it is going to be the high tension, or the 11 kilovolts of electricity is going to be passing through this wire, entering into our step down transformer. And you can see that there are 3 wires entering into our step down transformer, right? Now, once these 3 wires enters into our step down transformer, 4 wires are going to come out of the chest of the step down transformer. Now, these 4 wires, you can see these 4 wires are entering into what? This is what we call our feeder pillar. So now this feeder pillar now is going to now transmit this our steps down electricity, and then it is going to be transmitted on poles. Now these poles now might be wooden poles, it might be concrete poles, and the wire itself can also be passed underground. Right? So now if you look at this now, you can see that after the 4 wires enters into our feeder pillar, now let's trace. You can see these 4 wires going out. Now you can see that our poles are carrying the 4 wires, and then from these poles now, or from these 4 wires rather, each houses now will not be tapping directly from it. So now house number 1 will tap from these 4 wires, house number 2 will tap from these 4 wires, and then house number 3 will tap from these 4 wires. So you can see how the process goes from generation down to what? Distribution. Right? You can see it's as easy as ABC. So when next you see all these electricity lines or electricity cables, you would understand the process at which this electricity are being transmitted. Right? Good. So now what does this mean in terms of our measurements? If you go further now, you can see what we have here. We see that our measurement guide, if you check our standard method of measurement for description requirements, right, you can see what we have here. For high voltage cables, you measure them in what? Meters. All you just need to do is to get the distance of the high voltage cable and determine the length in meters, multiplied by the number of cables we have, whether it is for high tension or low voltage. Remember I told you that if the electricity is passing is transmitting high voltage electricity, how many wires are going to be transmitting high voltage electricity? Remember I said there are going to be 3 wires. And if the electric cable is carrying low voltage electricity from the transformer, it is also going to be measured in meters. And the number of cables are going to be 4 in number, coming out of your step down transformer. So you can see this as ABC. For high voltage cables, get your length of the cable in meters. For low voltage cables, get the length of your cables in meters. Now for pylons, now remember I said that pylons are our poles. So those electric poles that you see, right, these are what we call pylons. These electric poles that you see, how do we measure them? We measure them as enumerated items. So you count the number of poles. So if you look at this now, you can see the way these poles are spanning distances from one center to center dimension. So you can see you can now count. So this is pole number 1, pole number 2, pole number 3, pole number 4, pole number 5, and so on and so forth, depending on the number or the distance of the cable, right? So if, for example, the cable is going to be 20 meters, and you are going to be seeing a pylon at every 1 meter. So it means that you are going to be having how many pylons? 20 in number. I hope that makes sense. So you just get the total length of the cable divided by the center to center spacing, and you get your number of pylons. So to measure that, all you just need to do is to count the number of pylons and then describe whether the pylon is going to be a steel pylon or a concrete pylon. When I say pylon, I mean pole. A concrete pylon or a wooden pylon. You describe it so that the builder can know, or so that when they are procuring those poles, we can know what exactly we are going to buy in the market. Good. So now, primarily, before I move further, shackles or insulators. What are shackles or insulators? Now, if you look at this, You see this stuff that look like rings on top of our poles, right? Those are called shackles. So these shackles can either be what? Disc shackles or insulators, or pin shackles or insulators. Now this is an example. This one's here is an example of what? A disc shackle or a disc insulator. Why this is an example of what? A pin shackle or a pin insulator. Right, I hope that makes sense. Good. So your shackles or insulators are measured in what? Number, enumerated. So all you just need to do is to count the number of shackles. Guys, please like the video if you're enjoying, if you're getting information on this live stream. Don't forget to like the video, please, guys. Like the video. Don't forget, like the video. Good. So moving forward, primary equipment. Example of our primary equipment are our transformers. So all the transformers we've been talking about, whether step-up transformer or step-down transformer, they are under what? Primary what? Equipment. Good. So now our step-up and step-down transformer are measured as what? Enumerated items, meaning that you should count them, right? So if our step-down transformer is 1, all you just need to do is to tell us that we are going to be having just one transformer. So you describe what kind of transformer it is. What is the rating of the transformer? Where is the transformer going to be located? Is it going to be mounted on the pole, or is it going to be mounted on the ground? So you are going to be getting that in your what? SMN on how to carry out your what? Description. Good. So now, after our step up or step down transformer, the next item is what? Your feeder pillars. Feeder pillars are also categorized as what? Primary equipment. So your feeder pillars would be measured as also enumerated items. So all you just need to do is what? Count. Tell us the number of what? Feeder pillars that needs to be what? Procured. Good. The next one is what? High tension panels or low voltage panels, whatever the case may be. Now they use these high tension panels in cases where you are looking at commercial buildings, commercial buildings like maybe like Dangote refinery now. It's going to be needing high tension panels to distribute electricity. It's also going to be needing low voltage panels to distribute electricity over what? A long distance, right? Good. So now your high tension panels is measured as enumerated items, meaning you should count. Your low voltage panels is also measured as what? Enumerated items. So the last thing I was also going to put here are your fittings. Fittings are not under primary equipment, they are under terminal equipment. But that is going to be for another video, right? I just want you to understand the concept of generation down to distribution. In our next video, we're not going to be looking at the final circuits proper. After the electricity has been distributed into your house, how do you now connect that electricity to different electrical fittings? That is now where we now talk about our what? Final circuit, which I'm sure that is what what most of us are conversant with. The final circuit, how to measure the distribution board, how to measure your sockets, how to measure your wires and cables, how to measure your switches, and so on and so forth. So that is going to be under our final circuit. We are going to be treating that in a different video entirely. Good. So that is that for this video. If you enjoyed this video, let me know in the comment section. Just tell me I enjoyed this video. Thank you very much. Just let me know in the comment section, and if there are any questions, just let me know. This is time for question and answer. Right. Let me know your questions in the comment section. So guys, if you would like to support the channel in any way, you can do that by sending us a super chat. I don't know if it's possible, if I can get about 10 super chats before I end the live. So just let me know your questions. in the comment section, right, so that I can answer them. If you have any question, just let me know so that I can answer them. Let's say the next class might, let's just say on Monday, by the grace of God. On Monday, by the grace of God, we're going to be going into final circuit and other things that you need to know when it comes to measuring for electrical works. So if you have any question, just let me know in the comment section, guys. I also want to let you guys know that we have a membership. You can also support the channel by joining our membership. The membership are of 2 tiers. The first tier is for the support. If you want to be supporting the channel on a monthly basis, you can do that by subscribing to our membership. Yeah, you can do that by subscribing to our membership. There's the support tier and there's the master's class tier. The support tier is if you want to support the channel. The master's class tier is for exclusive contents that are strictly for our members. So let me know if you have any question, guys. By 8:15, I'm going to be ending the live stream. So if there are any comments, please, are we going to be having mechanical and plumbing? Okay, yes, we would. I don't know how soon because we have to finish what we started, which is electrical, right? But yes, I'm going to be also touching on mechanical and plumbing soon because this is basically MEP. When we say MEP, we mean mechanical, electrical, and plumbing. So we're going to be touching each and every one of them. I don't know how fast we're going to be touching them, but I can assure you that we're going to be touching them. So guys, any more question? By 8:15, we'll be ending the live stream. So guys, you can support the channel by sending super stickers and super chats. It will really go a long way for the channel. You know, the thing is, YouTube, one of the major reasons why I opened this channel was because I would like to enlighten people and also to use this as a, as a side hustle or a partial stream of income. But YouTube is kind of difficult now because I don't know why, but most of my viewers are African viewers, right? And African views generate low income. African views generate low income, so you can say that it's difficult earning on my channel, right? So it will really go a long way if you guys support the channel. And before I can withdraw what I generated, the income I generated from YouTube, you have to have like a minimum amount generated, which is $100. And my channel, this channel got monetized last year April, and we haven't even clocked $50. So you can see that it can be annoying and a bit, tiring, because I know I put a lot of work into the videos that I make. It takes me close to 3 to 4 hours to create a video. Yeah. And, It can be tiring and heartbreaking at the same time because I talk for 4 to 5 hours and it's not generating enough income. So yeah. So support me guys, support the channel. So yeah, this is 8:16. So we're ending the live. Thank you very much guys for joining, and we'll see you in the next stream.